Okay, I don't have a textbook anymore. It is in use. So this is the problem that we're looking at. Find the maximum vertical distance d between the parabola y equals x squared minus 2x minus 2 and the line y equals x plus 3, negative x plus 3, for the shaded region. So it just means within that shaded region there is a value for x somewhere here for which the y on the line and the y on the curve is at a maximum distance. We don't know where that is, so we're going to have to calculate it. We can see that y on the line minus y on the curve is just a y minus a y. So y equals that stuff, and this y equals that stuff. This is y on the line, that's y on the curve. So I can take y on the line, which is negative x plus 3, and subtract y on the curve, which is that stuff, and it will give me a result. The result is called d. So we can write it this way. D equals y on the line, negative x plus 3, minus y on the curve, which is known as x squared minus 2x minus 2. And that looks suspiciously like a parabolic function. So if we clean this up a little bit, what that means is it equals negative x squared minus x minus 2x, that's plus x, plus 3 minus 2 is plus 5. So d equals that. This would be a curve. Now I need to think about this a little bit. This would be a curve where it's a downward facing curve, so it would look like this. And there would be a vertex. And on that vertex, the vertex would have a coordinate, x, y, and actually also known as hk, if we do it in standard form. Doesn't matter if you call it hk or xy or whatever, but this value right here, k, that's our buddy. That is the value here, which is actually the maximum amount of this curve, and the curve here represents the distance, and the distance is the distance between the line and the curve. So don't be confused about the fact that the problem started out with a different line and curve. It started out with a curve and a line and a shaded area and all this kind of nonsense, and you're looking for these distances. So that distance there is bigger than this distance here. And of course, for any y on the line, there's a corresponding y on the curve. There's a little YL and a YC. So this distance and this distance will change depending on the value of x. And that's what this shows. This just shows that d, the distance, that's that distance here, equals whatever gets calculated by this crap. And this is the line, or this is the value of y on the line, this is the value of y on the curve. So given that, we forget about this, because once we graph this, it actually looks like that. It's a bunch of differences. It gets to a maximum and then it starts getting smaller again. And think about it. The distance is small. It gets bigger, it gets bigger, it gets bigger, it gets bigger. At some point it starts getting smaller again. That's what this shows. It gets bigger, 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 and then it starts getting smaller again. So what we have to do is find out h and k from this. Two ways of doing it. You may recall the vertex formula, and the vertex formula, the formula for the y of the vertex is c minus b squared over 4a. That's the formula for y and the vertex. And c minus b squared over 4a is 5 minus 1 over negative 4, which is 5 minus a quarter. It's 5 1/4, which equals 5.25. That easy.